Hello, Mr. Chu here with Tray Arithmetic Plus. Let's talk about finding the greatest common factor. In example 1, we're going to find the greatest common factor of 3 numbers. And in example 2, we're going to factor out the greatest common factor. So, if these videos help you, give it a thumbs up and like it. You can also subscribe to my YouTube channel, and there's a link if you're on a computer down here, or you can find that subscribe button underneath the video on your device. Alright, so in black here I've written, write the prime factors of all the terms. So some students will use a factor tree, and that's okay if you need to do it. And then you have to circle, you line them up, circle the common factors and find the GCF, and then for example 2, factor it out. So if you're someone that needs a factor tree, we'll take the first one. I'm going to do it in black, and I write a factor tree. That's 2 times 4 is 8. So I can do 2 times 4 and I get that number up above. And then the 4 is 2 times 2. And there's my 4. So my prime factorization of 8 is 2 times 2 times 2. So I just write that down. All right. Now we're going to go to 12. So I always factor out and divide by the smallest prime number when I'm doing this. It just makes it easier. And then 2 times 6 is 12. And then the 6 is 2 times 3. These are all primes. Now when I was teaching this in middle school, I'd have them circle those primes. Just something else that you can do. All right, and then we have 32. So 32 will be the biggest one here, or longest one. It's going to be 2 times 16, 2 times 8, 2 times 4, and 2 times 2. So 32 is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. And then you can always check this by multiplying across. 2 times 2 is 4 times 2 is 8. Yep, they are equal. 2 times 2 is 4 times 3 is 12. Yes, they are equal. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. Yep. So those are 8, 12, and 32's prime factors listed underneath each other. Now look at the second line here. Circle the common factors and then find the GCF. So I circle the common factors by finding the number that's in every one of them. It has to be common to every one. Well, do you see how that has a 2 in every one, and so I circle it? And since I circled that, I use that as a factor to find my GCF. Well, are there any more? Well, there's another one. Now, I can't circle this 2 because there's no longer a 2 here. I can't circle the 3 because there's not a 3 in either one. And it doesn't matter that there's a 2 in 2 of the 3 for it to be a GCF. All right, so now I multiply. 2 times 2 is 4. And then that is the GCF. That means that I could divide all 3 of those by 4, and that is the biggest number I could divide them by. And when I divide by 4, what is left? 2 and the 8. Because 8 divided by 4 is 2. I'll show you how that works in a minute. 12 divided by 4 is 3. 32 divided by 4 is 2 times 2 times 2, which is 8. All right, that's just doing a simple GCF of 3 numbers. Now, what happens if you are supposed to factor the GCF? And I'll write that here. factor the GCF out of this expression? Well, we follow the same rules. We have to list all of the factors. So, let's go ahead and let's start with the 16 x squared y. So I have my 16 x squared y, and the 16 is 2 times 8. The 8 is 2 times 4. The 4 is 2 times 2. And then I've got an x, and a y. You just write those down. So I have 2 times 2 times 2 times 2, x, y. All right? Now we're going to do 32 xy squared. So 32 xy squared is going to be 2 times 16, and then it has the rest of these. 2 times 8, 2 times 4, 2 times 2, and then I have an x, a y, and a y. So now I write these underneath. Now I do my 48 xy squared, or xy, sorry, 48 xy. It's 2 times 24. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. And we have an x and a y. So that's 2 times 2 times 2 times 2 times 3 xy. All right, so now I can say all I have to do now is circle what's common. It's got to be in every one of them. And when you circle it, it becomes a factor in your GCF. I circled all those 2's, so I write it down as a factor. I circle all those 2's, I write it as a factor. I circle all those 2's, I write it as a factor. I circle all 3 of those 2's. Remember, it has to be in every one of them. I write it as a factor. I cannot circle this 2 and this 3. But, look, I've got an x in all of them. So, I can circle that. And then I've got a y in 3 of them. So now I multiply this to find my GCF. 2 times 2 is 4, times 2 is 8, times 2 is 16 xy. So now you're saying, yeah, but what exactly does that mean? All that means is that's the biggest number that I can divide them all by. So that would be factoring out the GCF. So I'm just going to write this up here so that it can be easily seen, because we don't need these factor trees anymore. I'll just get rid of these. So now to factor this, I write my GCF. And then I'm going to write in parentheses. And we're going to multiply that and reverse the distributive property. So, what goes in here? It's very simple. Find something that has not been circled. And I'm going to circle it in green. There's an x. If all of them were circled, you would put times 1 and you'd put a 1 up there. That's the only time that's a little bit different. Then I look across here, and what is not circled? This 2 and this y. And then in the 48, what's not circled? The 3. So if I would take and do the distributive property, 16xy times x is 16x squared y. That's right. And then 16xy times 2y. 16 times 2 would be my 32. And I've got an extra y, xy squared. That's right. And then the 16xy times 3 would be 48xy. I did that right. Okay, I'm going to offer you a couple of challenge problems now that you can work on. And then you can pause this while you're working on these. Get out a piece of paper, try these, and see if you can get these right now using the prime factorization. So, here they are. Challenge 1. I just want you to take these three and find the GCF using primes. What are the numbers? 15, 45, and 60. So there's your first challenge problem. The second challenge, you're going to be finding the GCF of an expression. Here's challenge 2. So we want you to factor the GCF using primes. Okay, here it is. 9 a squared b to the third plus 18 a to the third b squared minus 36 a squared b squared. All right, now remember, there will be a link up here at the end of the video that has these two problems worked out. In the meantime, you can pause this, work them, check it, see how well you did. Make sure you like this video if it's helpful. Subscribe to my channel. And remember, I'm Mr. Chew. This is Triarithmetic Plus, which means it's pre-algebra. And I want to help you learn the math.